I think this might be the last year they're doing online night school, to be honest with you. I don't think they're going to do this anymore after this year. I think you guys are the last group that's going to be doing it online. And then I think next year is when they're going to start doing it in person. So for all of you physics people, congratulations. This might be probably the easiest unit for you. For all of you not taking physics, or took physics last year, you're still probably good. But if you're new to this whole physics stuff, whatever, it is what it is. I'm not going to make it overly complicated for you. They're going to go through the first two lessons. So we're going to be talking about review of angle theorems and sine and cosine laws, which is what we've done before, or what you have done before. So in a triangle, when two angles and a side are given, or a contained angle are given, the other sides and angles can be found using the sine law. So for example, this is angle B over here, corresponds to side B, angle A corresponds to side A, and angle C corresponds to side C. So the sine law is sine A over A is equal to sine B over B, which is equal to sine C over C. The top part is where you are going to be finding a missing angle because our sine A, sine B, sine C are in the numerator. However, if you want to find a side, it would be better for you to just use the reciprocal, which is A over sine A is equal to B over sine B, and is equal to C over sine C. So when you're finding your angle, use the top one. When you're finding a side, use the bottom one. Now, cosine law. When triangles in which all three sides are given, or two side lengths and the contained angle are given, then the cosine law must be used first to solve a triangle. So I have a squared is equal to b squared plus c squared minus 2bc cos a. You have your formula for b squared and c squared. This is for finding a side. Or if you want to find an angle, this is to find an angle. We have cos A is equal to b squared plus c squared minus a squared over 2bc. We have it for cos B, and we have it for cos C. Is everyone cool with sine and cosine law so far? Pretty easy stuff, right? Now next, we're going to review angle theorems, which is things you have done from grade 9 and 10. So supplementary angles is angles that add to 180. So I have angle A and angle B. If I add those together, I get 180 degrees. So for example, if angle A is 60 degrees, what does angle B have to be? Well, angle B should be 60 because angle A is obtuse. So if angle A is 60, what would angle B give me? If you're using supplementary angles. Come on, guys, grade 9, grade 10 math. What would angle A be if angle B is 60 degrees? 120. So this is going to be 120 degrees. Now the complementary angle theorem is where angles add up to 90 degrees. So I have this angle, which is 90 degrees, and I can split it up in two angles, which is angle A and angle B, which means both of those have to add up to 90 degrees. Now I have the opposite angle theorem. So if this angle is 150, that means this guy over here is 150 as well. So 150 gives me 300, which means I have 60 degrees left over to split in between angle A and B, which means that angle B is going to be 30 degrees and angle A is going to be 30 degrees as well. So the sum of angles in a triangle theorem. So remember, the sum of all angles in a triangle is going to be 180 degrees. Now if we have an isosceles triangle, that theorem states that angle B and angle C are going to be equal to each other. and angle A is going to be unique. And then last but not least, I have the exterior angle theorem. So the exterior angle of a triangle equals to the sum of two remote interior angles. Okay, so angle A plus angle B gives me angle C. However, if I have, say I want to find angle D, I still take, I take 180 and subtract it from C. So if I want to find angle D, I can take 180 and subtract from C. So again, these are just basic things that we have learned about in grade 9 and grade 10. So the sum of interior angles in a quadrilateral, so remember the sum of a four-sided quadrilateral is going to be 360 degrees, which means that the sum of interior angles of any polygon with n sides is 180 bracket n minus 2. So if I have a pentagon, my pentagon is 5 sides, so 180 times 5 minus 2, which is equal to 180 times 3. So the sum of interior angles in a pentagon is going to give me 540 degrees. So again, simple stuff. And now we have lovely patterns. Who remembers these patterns from grade 9? And who here liked them, disliked them? They were mad, I forgot all about them. Too bad, you gotta remember them now. So we have corresponding angles are equal, so I have my F pattern. So as you can see, I have my F pattern over here, which means angle A and angle B are the same, okay? So angle B is equal to angle, so angle A is equal to angle B. Then I have my alternative pattern, which is my Z pattern. Remember, these two angles over here are going to be the same. And last but not least, I have supplementary angles, or my co-interior angles. Oh, that was weird. Are supplementary between A plus B is equal to 180. So I get my C pattern. So A plus B gives me 180. So if I have one of those angles, I'm able to find the other angle by taking 180 and subtracting from that given angle. So is everyone ready to practice your sine law? Because it's going to happen. So in triangle ABC, angle A is 80 degrees, AB is 512, and AC is 76 kilometers. Solve the triangle. When I say solve the triangle, what am I solving for? Let's see if you guys remember this. When I say solve the triangle, what am I solving for? I'm solving for all sides and angles. So what would be the first thing that we would use or that we could solve for? What would be the first thing that we can use, and what are we going to solve for? What is our first? What's the first thing that we want to do? we'll use cosine law because we have two sides in a contained angle. So my sine law is going to be a squared is equal to 76 squared plus 512 squared minus 2 times 76 times 512 times cos of 80. So who can tell me what the right side is equal to? When you compute all of that, what is my right side equal to? So who can compute the right side without square rooting it? What would my result be? This is all in degrees. Do not use radians. Let's see, anyone can come up with the solution. Okay, thank you, Priyanshu. So before we square root, I'm going to get 254,406, my approximate measurement, which means that if I square root it, I get approximately 504.39 kilometers. So I know my side A is going to be 504.39 kilometers. So now I'm able to solve for one of the angles. So which am I going to use to solve for my angle? What law? Sine or cosine? Sine law or cosine law? We will use sine law. So I'm going to use the angle that I have and a side. So remember, because we're finding an angle, I'm going to have my sine ratios at the top. So you're going to have sine A over A is equal to sine B over B. Which means my sine A is going to be, so when I isolate for sine B, I get B. Sorry, this should be lowercase b. B times sine A over A is equal to sine B. So my side B is going to be 76 times sine of 80 divided by 504.39 is equal to sine B, which means that B is equal to sine inverse of 76 times sine of 80 over 504.39. Who can tell me what my angle is going to be for angle B? Eight and a half. So my angle B is approximately 8.53 degrees. So this is 8.53 degrees. which means what's the easiest way for me to find angle C? So how am I going to find angle C? Yep, so I do 180 minus 80 minus 8.53, which gives me angle C. As a measurement, I have 91.47 degrees. So is this pretty easy, guys? Super easy. Nothing to complain about. Everyone's happy. I'm happy. We're all good. So I'm going to move on to the next example. So now I'm going to be talking about bearings. So a compass bearing of an object is the measure of the angle between due north and the line of sight of the object in navigation vectors used to describe a bearing or position. So a true bearing means a direction measured from due north and rotated clockwise until we have the given angle measured. If a bearing is negative, we move counterclockwise from due north. Always use 3 digits to be in proper form. So 0, 0, 0 degrees would be considered north. So which means this guy here is going to be north. 145 degrees would be in the lower right quadrant. So from here to here, this would be 145 degrees. And this is 145 degrees clockwise from due north. So everything is either going to be referred from north or south. Okay, again, if you've done physics, this might be a bit of review for you. So a quadrant bearing is a direction measured from either north, south, and rotated the required angle measured toward west or east. We rarely use east or west as an initial point of reference. For our purposes, we never use east or west as a final solution and the initial point of reference. So for example, we will write south 30 degrees east, not east 60 degrees south. And I'll show you guys what this means. So we're always going to express the angle between 0 and 90 degrees to be in proper form. So for example, south 70 degrees west can be converted to an equivalent true bearing as 250 degrees. So for example, this is my quadrant bearing because I'm using this acute angle as 70 degrees. Southwest, remember this is south and this is west. So it's going to land in quadrant 3. So this is my quadrant bearing. My true bearing can be expressed as 250 degrees if we start from here and go clockwise all the way to our terminal arm, and this would be considered 250 degrees. So northeast will always be written as north of 45 degrees east or 045. So it would look like this. So again, this is north, this is east. This 45 degree angle here is going to be north 45 degrees east. If you're going to write southeast, which is in this quadrant over here, south and east, and this is 45 as well, but if we start from our north point and go counterclockwise, this turns out to be 135 degrees. So we can write this as south 45 degrees east. Next, we can find northwest. Remember, our bearings are always clockwise, so this is north, this is west, this would be 45 degrees, which means this is north, 45 degrees west. Or again, if we start from north and go counterclockwise from 0, 0, this becomes 315 degrees. And last but not least, our bearing southwest, which is right here. Again, this is south, this is west, this is north, and we always start at 0, 0, 0. This is south, 45 degrees west. Or if I start from 0, 0 and go all the way clockwise, this is also the same thing as saying 225 degrees. Okay, so that is that for that lesson. Okay, so hopefully it's nothing too crazy hard, and hopefully everything is fine.